Hello students, welcome to our new lecture of magnetic effect of current and magnetism. So in previous lectures we were discussing about galvanometer. So in today's lecture we will continue about galvanometer and discuss some topics which we have not discussed in our earlier lecture. So in today's lecture our first topic will be sensitivity of a galvanometer. So before starting sensitivity of galvanometer, first we will understand what is the meaning of term sensitivity. To understand sensitivity, I will take two examples. In first example, suppose you have a chair which have wheels on it and you are pushing it. So when you apply force on the chair, it starts to move. And in other example, consider you have a car. Now you are pushing this car with same force, but this time car will be a little bit difficult to move. So we can say that this chair is more sensitive than the car. Why? Because for the same value of force, the chair moves more than the car. So we can define sensitivity as for the same input, which machine has more output is called more sensitive. So we can apply this concept in galvanometer too. In galvanometer, we also have one input and one output. We take current as input and what is our output? So deflection in the coil is the output. So if you have two galvanometer and for the same value of current, one galvanometer has more deflection than the other, then we call first galvanometer as more sensitive. So we can take current and voltage both as the input. So we have two type of sensitivity. Number first sensitivity is current sensitivity of galvanometer and second sensitivity is voltage sensitivity of galvanometer. So first we will discuss about current sensitivity of galvanometer. So we can define it as if for the small value of current coil has a large deflection then galvanometer is called more sensitive, and we define its sensitivity as the ratio of deflection of the coil to the input current is called current sensitivity. We denote current sensitivity by SI, current sensitivity. So we can write down current sensitivity is equals to deflection of coil of galvanometer divided by input current. So SI will be deflection in the coil is phi and input current is I. Now we will have to put this value of I. So first we will find it. So in earlier lecture we have discussed that torque acting on the spring will be C phi and torque acting on coil will be N AB, where C is the modulus of rigidity, phi is the deflection of coil, N is number of turns in coil, A is equals to area of coil, and B is magnetic field of coil. So we will put them equal. So C phi will be equal to N A B. Sorry, its formula is N I A B. N I A B. So we will find I is equal to C phi upon N A B. Now we will put this value of phi in this equation. So we will find SI is equals to phi upon, what is the value of phi? C phi upon N A B. N A B. Phi is cancelled with phi. So we can write down SI is equals to N A B upon C. So it is the formula of current sensitivity of galvanometer. So how can we increase sensitivity of a galvanometer? So we will find it out. To increase sensitivity of a galvanometer. How can we increase current sensitivity? So number first, you can clearly see here, if we will increase number of turns, then value of SI will be increased. So to increase sensitivity, number of turns should be as more as possible. So number of turns should be as more as possible. Number second, you can see that if we will increase area of the coil, then sensitivity will also increase. So area should be increased. Number third, if we increase magnetic field, then sensitivity will also increase. So intensity of magnetic field should be more. And if we increase this value of C, then this sensitivity will decrease. So to increase this sensitivity, value of C should be decreased. So spring should be selected such that it has as small as possible modulus of rigidity. So C should be decreased. So students, note it down. Then we will discuss about voltage sensitivity of galvanometer. Now we will start voltage sensitivity of galvanometer. So we can write down, if for a small value of input voltage, there is a large deflection in the coil, then galvanometer is said to be more sensitive. So we can define it, the ratio of input voltage, the ratio of deflection of coil to the input voltage is called voltage sensitivity. It is denoted by SV, voltage sensitivity. So we can write down SV is equals to deflection in the coil of galvanometer divided by input voltage. So SV will be equal to deflection in the coil is phi and input voltage is V. So according to Ohm's law, we can write down V is equals to I. So SV will be equal to phi upon IR. And value of input current is C phi upon NAB. So we will put this value in this equation and we will find SV is equals to phi upon C phi upon NAB. This phi is cancelled with this phi and also this phi. So we can write down R. So we can write down SV is equals to NAB upon CR. So it is the formula of voltage sensitivity of a galvanometer. So how can we increase the sensitivity of galvanometer? To increase voltage sensitivity, number first. If number of turns in the coil will be more, sensitiveness will also be more. So we can write down number of turns in the coil should be as more as possible. Number second, area of coil. So if area of coil will be more, current sensitivity will also be more. So area of coil should be maximum. Number third, intensity of magnetic field. If intensity of magnetic field will be more, then sensitivity also be more. Number four, modulus of rigidity. So we can clearly see that if value of C will be increased, then value of S will be decreased. So if we want sensitiveness more, then we will have to choose spring material such that it has very less modulus of rigidity. So value of C should be as less as possible. And last, number 5, resistance of the coil. So we can clearly see that if resistance will be increased, then sensitiveness will decrease. So to increase the sensitivity of coil, the resistance of the wire of coil should be as less as possible. So these are the some factors which can increase voltage sensitivity of a galvanometer. So students, note it down. So students, now we will start second topic of our lecture, which is shunt. So before studying about shunt, we will discuss about the coil of galvanometer. Generally, coil of galvanometer is made up of very thin copper wires. So whenever there is excessive current passes through this coil, a large amount of heat is generated in this coil, and which can damage this coil of galvanometer. Also, a large current in galvanometer can also produce large deflection in the coil. So pointer of the galvanometer may break. So to prevent the coil of galvanometer from any of these damages, a low resistance wire is connected with parallel combination with the coil of galvanometer, and and this low resistance wire is called shunt. So let's start our topic, which is shunt. So we can define this. Shunt is a low resistance wire joined in parallel combination with the coil of galvanometer from coil of galvanometer to prevent it from any damage. So now consider we have a galvanometer and its resistance is G, and the current passing through this galvanometer is Ig. So we will use a low resistance wire. Say its resistance is S, and we will join it in parallel combination. So we have joined it in parallel combination, and current passing through shunt is Is. So suppose total current is I. So we can see here that galvanometer and shunt are joined in parallel combination, and in parallel combination potential difference across all the resistances is the same. So potential difference across this galvanometer will be V, and potential difference across this shunt will also be V. So for the galvanometer V should be equals to Ig into G, and for the shunt voltage will be equal to Is into S, and these both are equal, so we can write down Ig into G is equals to Is into S. So we can write down it as G upon S is equals to Is upon Ig. Now I will add 1 at both sides. So we will find S, and S plus 3 is equals to Ig into Is plus Ig. But we can clearly see at that junction that I is equals to Is plus Ig. So we can put here S plus G upon S is equals to I upon Ig. Now we consider that if nth part of total current is allowed to pass through galvanometer, we have considered that only nth part of total current will pass through this galvanometer. So we can write down that current passing through galvanometer is nth part of total current. So we can write down I upon Ig is equals to n, and we will put that value here. So we will find s plus g upon s is equals to n. So s plus g is equals to ns transpose this s, so g will be equal to ns minus s. So g is equals to, s will be common, n minus 1. So we can write down s is equals to g upon n minus 1. This expression denotes that if we want n part of the total current should be passed through the galvanometer, then resistance of shunt should be selected such that it is the n minus 1th part of resistance of galvanometer. So we can write down, if nth part of total current is to pass through the galvanometer, then resistance of shunt should be n minus 1th part of resistance of galvanometer. So students, note this topic. We can also find current passing through galvanometer with this equation. So we can write down S plus G upon S is equals to I upon Ig. So value of Ig will be equal to S upon S plus G into I. So thank you students, we will end today's topic here.